For our first example, let's suppose that on average, every 100 years the town of Castle Rock experiences a major earthquake. There is thought to be a 5% chance that this town's natural rock formation would collapse during a major earthquake. Due to regular erosion, it is also believed that there is a 0.07% chance that this formation would collapse in any given year. We ask, what is the probability that there is a major earthquake in the same year that the formation collapses? First, let's identify what we're being asked. We're being asked about the probability of a major earthquake the same year that the formation collapses. So our question is to assume that the formation collapses and then ask, what's the likelihood that there is also an earthquake? What are the things that we know? Well, we know that on average, every 100 years, there's a major earthquake. So the probability of an earthquake happening in a given year is 1 over 100, which equals 0.01. We know that there's a 5% chance that this rock would collapse during an earthquake. This tells us if we know that an earthquake is happening, the probability of a collapse occurring is 0.05. Lastly, we see that there's a 0.07% chance that in any given year it would collapse. So this is just a statement about the probability of it collapsing in a given year, and it's 0.0007. At this point, we've gone over multiple formulas for the probability of E given C. By the definition of conditional probability, we have that this is the probability of E and C divided by the probability of C. Or we could use our method of mapping out the probabilities and using the multiplicative property to say that this is the probability of E times the probability of C given E divided by the probability of C. Lastly, by Bayes' theorem, we could say this is the probability of E times the probability of C given E divided by the probability of E times the probability of C given E plus the probability of E complement times the probability of C given E complement. In this case, this middle expression seems to be the most appropriate for our given information. So we can find the probability of a major earthquake happening given the formation has collapsed as 0.01 times 0.05 divided by 0.0007, which works out to be 0.714. So there is a 71.4% chance that there will be an earthquake happening the same year that it collapses. For our second problem, we want to consider a dog food company that's doing research on single dog owners and found that 27% of single dog owners had a small dog, 39% had a medium-sized dog, and that 34% had a large dog. They also found that by dog size, the probability that the owner would purchase food from them was 74% for small, 80% for medium, and 60% for large. They want to know, of single dog owners that buy their food, is it more likely that they have a small dog or a large dog? From this problem, we find that the probability of a single dog owner having a small dog is 0.27. A medium-sized dog is 0.39. The probability of a large dog is 0.34. We also know that the probability of a single dog owner buying this company's food, given they have a small dog, is 0.74. Given they have a medium-sized dog is 0.8. And given that they have a large dog is 0.6. We want to find and compare the probability of someone that purchased the food having a small dog, the probability of someone who purchased the food having a large dog. Here we'll want to use our extended Bayes theorem, which will tell us that the probability of S given F will be the probability of S times the probability of F given S divided by the probability of S times the probability of F given S plus the probability of M times the probability of F given M plus the probability of L times the probability of F given L. Plugging in for our known quantities, we see that this will equal 0.27 times 0.74 divided by 0.27 times 0.74 plus 0.39 times 0.8 plus 0.34 times 0.6. And that this should work out to be 0.279. In a similar fashion, we can find that the probability of L given F will be 0.34 times 0.6 divided by 0.27 times 0.74 plus 0.39 times 0.8 plus 0.34 times 0.6, which equals 0.285. This tells us that amongst single dog owners that purchase food from this company, it is slightly more likely that that owner has a large dog.